Standard form to scientific notation. When writing numbers in scientific notation, first identify the coefficient of the converted number. Then, determine how many places the decimal will need to move to create that coefficient. For positive numbers greater than 10, the decimal will move to the left. For positive numbers less than 1, the decimal will move to the right. Let's start with some examples with positive numbers greater than 10. The first step in converting 3,780,000 to scientific notation is to note that the coefficient must become 3.78, and that achieving that will require moving the decimal to the left 6 places. So you can say 1, 2, 3, 4, 5, 6. To move the decimal, we have to divide by 1,000,000. Since it's 6 zeros, we'll move the decimal 6 places to the left. To maintain the number's value, we also multiply it by a number with the same value, 10 to the 6. So we're going to multiply by a version of 1. So 10 to the 6 divided by 1,000,000 is 1, since those are equal, these numbers here. So therefore, it becomes 3.78 times 10 to the 6. But there is an easier way to go from here to here, and it's just to count the number of places you've moved. So for example, 1, 2, 3, 4, 5, 6 means it will become 3.78 times 10 to the 6. The shortcut for converting to scientific notation has the same first step, deciding how many places the decimal needs to move to create the needed coefficient. Then move the decimal to that location, multiply by 10, raised to a power equal to the number of places the decimal was moved. This is what I just explained on the previous slide. Moving the decimal to the left requires a positive exponent. This is justified by the process we followed on the last slide, but saves creating an equivalent fraction equal to 1 and multiplying it all out. This shortcut makes use of the conversion we just did while simplifying the process. Use the shortcut to write 870,000 in scientific notation. So first, write the number without the comma. Then place the decimal so that the number will be less than 10 but greater than or equal to 1. So just remember that right now the decimal isn't shown, but it is right here. So we're going to move it to the left 1, 2, 3, 4, 5 places. And remember, we're not going to move it here because that would give us a coefficient less than 1. Remember, we want the coefficient to be a number between 1 and 10. So 8.7 is where we want that decimal. So because we had to move the decimal 5 places to the left, we're going to multiply the coefficient by 10 to the 5th. Let's express 284 million in scientific notation. So first, write the number without commas. 284 and then 6 zeros. So right now, our decimal is here. Place the decimal so that the first number will be less than 10 but greater than or equal to 1. So we're going to want it to go right there, 2.8. So we go, or I'm going to say 1, 2, 3, 4, 5, 6, 7, 8. All right. So I'm going to write all those zeros out. How many places did you have to move it? Let's count again. 1, 2, 3, 4, 5, 6, 7, 8. Boom, we're done. You don't need all these zeros once you have this times 10 to the 8 thing here. Well, if you put the decimal here, you definitely need to have the times 10 to the 8 because at this point we've changed the value of the number. So we need to include this so that we have the original value here. All right, so here you have the number with no decimal. Then we figure out where to put the decimal so that the coefficient is between 1 and 10. It can be 1, but it can't be 10. And then we add times 10 to the 8th to make up for the fact that we've moved the decimal over 8 places. Then we drop all these zeros because we don't really need them anymore. Express 53,600 in scientific notation. First, we write the number without the comma. Then we're going to place the decimal here So it's going to be 5.3600. Then we need to make up for the fact that we've moved the decimal 1, 2, 3, 4 places. So times 10 to the 4th. Then finally we can get rid of those zeros. 5.36 times 10 to the 4th. And we are in scientific notation. And there you have it, all the answers. Here we go. There's our answer. This giant number here is the mass of our solar system. How do we even say this number? Let's use scientific notation. All right, rewritten in scientific notation, we have 3.0 times 10 to the 53rd kilograms. That is a lot easier to write and say. The first step in converting small numbers to scientific notation is to note that the coefficient here must become 5.89, right? Because we still want that coefficient to be greater than or equal to 1, but less than 10. Achieving that will require moving the decimal 4 places to the right. 1, 2, 3, 4. To move the decimal, we have to multiply by 10,000. Since it's 4 zeros, we'll move the decimal 4 places to the right. To maintain the number's value, we also divide it by a number with the same value, 10 to the 4th. So therefore, we're multiplying by 1, but 1 is going to be 10,000 divided by 10 to the 4th, right? Because these are the same. So when you do that, you get this very tiny number, all of a sudden has become a large number, but to make up for that, you have to include the times 10 to the negative 4th. Once you have that in there, then this number here is equivalent to this number over here. The shortcut to converting to scientific notation has the same first step, deciding how many places the decimal needs to move to create a coefficient that's greater than or equal to 1, but less than 10. Then just move the decimal to that location and multiply by 10 raised to a power equal to the number of places the decimal was moved. Moving the decimal to the right requires a negative exponent. This is justified by the process we followed on the last slide, but saves creating an equivalent fraction equal to 1 and multiplying it all out. To express 0.0043 in scientific notation, first we write the number without the decimal point. Then we place the decimal so that the first number is greater than or equal to 1 but less than 10. So right here. So the coefficient is going to become 4.3. Count how many places you had to move the decimal point. So we moved it this way, 3 spots. So it was here, and then 1, 2, 3. We moved it 3 spots to the right. The negative of this number becomes the exponent of 10. Then we drop the extra zeros, and we get 4.3 times 10 to the negative 3rd. First, we're going to write the number without the decimal point. So I'm actually going to completely ignore that first 0. So I'm just going to write 0, 0, 0, 0, 0, 8, 3, 2. Place the decimal so that the first number is greater than or equal to 1 but less than 10. So that's going to go right there. So we're going to have 8.32. So we still have 0, 0, 0, 0, 0, 8.32. Count how many places you had to move the decimal. So because the decimal was here, we had to move it 1, 2, 3, 4, 5, 6 places. So then we have 0, 0, 0, 0, 0, 8.32 times 10 to the, I lost count. 1, 2, 3, 4, 5, 6. Negative 6. Then we drop these zeros and we get 8.32 times 10 to the negative 6. And we're done. And here is the answer. Express 0.0073 in scientific notation. First, write the number without the decimal point. I'm going to ignore that first leading 0 because it will get confusing. 0073. And right now the decimal is here, but we're going to move it. All right, we're going to put the decimal right there. It's in between the 7 and the 3. So we get 007.3. But because we moved 1, 2, 3 spots to the right, we have to times 10 to the 3rd, and that actually goes down into this line. Then finally, we cancel out those beginner zeros here, and we get 7.3 times 10 to the negative third. Oop, I forgot that negative sign. There we go. And there you have the answer. As you get farther and farther down a number line in the positive direction, your numbers are getting bigger. Therefore, really big positive numbers will have a positive exponent when written in scientific notation. As you get closer and closer to 0 on a number line, your numbers are getting smaller. Therefore, really small positive numbers will have a negative exponent when written in scientific notation.